Here we're going to discuss graphing lines. When graphing lines, it's really important to have the concept of slope down. Slope is actually like the fundamental idea. Slope is a rate of change, and calculus is the study of change. So slope is of the utmost importance as you move up the mathematical tree. But so you need to definitely have this formula straight up memorized. Slope is the change in y over change in x. You need to make sure that you have that down, and that you always need to have y in the numerator, the change in y in the numerator, and the change in x in the denominator. Sometimes students mix things up. They put the change in x in the numerator. Just be careful of that. Also, make sure that if you're going from this point to this point, you're going to do y2 minus y1. You have to start back on the second point and do x2 minus x1. So just be careful. Similarly, if you want to start here, you could do y1 minus y2. But then you have to start back with the first point, do x1 minus x2. So just be careful that you have everything lined up, and you're calculating things carefully and appropriately. And make sure you have the formula memorized appropriately. Also, just a little food for thought. I think slope is an M for the verb monter en français, in French, which means to climb or go up. Because something like this has positive slope, so M is greater than 0. Something like this is flat, doesn't change at all. And as we read English from left to right, this last one right here, from left to right, it goes down, so the slope is negative, aka less than 0. So those are really important conceptual ideas with slope. So this motivating example just goes over some key ideas. If anyone ever asks you to graph anything in your life, like this random equation right here, you may or may not know what form this is in. It's in y equals mx plus b, or slope-intercept form. But even if you don't know that, you can just make a table, and you can just literally guess some x values. Just make them up, and then plug them in, and test out and see what y is. And then plot those points. And then you'll have a nice picture. Another thing to think about that students tend to forget is that each point on this line makes this equation true. It is a solution to this equation. So really, this line is really just comprised of infinitely many dots. That's the way I want you to think of it. It's really infinitely many points that make that equation true. So when x is 1.27, you could plug that in and figure out what, in fact, y is. It's going to be perhaps an ugly decimal, but you can figure it out. Okay, so always have the courage and confidence to plug stuff in and make a table, especially if you aren't sure how the equation you're working with actually looks. One key idea that's going to follow us throughout the remainder of the course is any function I give you, you should have the confidence to plug in x values and see what y values pop out and plot those points accordingly, but also you should be able to find the y-intercept. Now what's interesting, to find a y-intercept, x is 0. And similarly, to find an x-intercept or any x-intercepts, there could be more than one. To find an x-intercept, you make y be 0. Now you might say, well, why is that? Well, let's just make a coordinate axis and think on this for a moment. Let's meditate on this. Here's x and here is y. Always remember the x is the horizontal axis. The y-intercept. Well, let's think of this location right here. That location, if you were to start out at the origin, is don't go left or right any, just go up some. Think of that from the origin, you're just going up some. If you're not going left or right any, to be somewhere on the y-axis, x must be 0. Every time. That anchors you to the y-axis. Similarly, let's make another point. Say here's our x-intercept. Let's say we have this line right here. Okay, cool. this x-intercept, and every x-intercept for that matter, you start at the origin, you go right or left to somewhere hit the x-axis, but you don't go up or down from the x-axis because it's the x-intercept. You're not going up or down. You need to be anchored to the x-axis, which means y is 0. You're not going to go up or down at all. You're just going to go left or right, and that's kind of how we say the coordinate of the x-intercept. So it's kind of opposite, if you will. If you want to find the y-intercept, you make x be 0. If you want to find the x-intercept, you make y be 0. So this idea is very, very important. You know, I might ask you, what's the y-intercept? X to the 5th minus 27x squared plus 43. Just plug in 0. And what's nice about plugging 0 for x is really kind of nice and quick and efficient. Plug in 0 for x, that's 0. That's 0. And you can kind of essentially just cover this stuff up. What's y? It's 43. So boom, you found the y-intercept as 43 on this quintic trinomial, if you want to get fancy. So now we're going to apply our slope formula, and this needs to be something that you have memorized. So I strongly recommend whenever you're asked to calculate the slope of anything, just label the first point. Remember, each point or location on a coordinate plane is x1 followed by y1. Or is an x followed by a y. Since this is the first point, we'll use the subscript 1, x1, y1. And since this is the second point, again, it's x followed by y alphabetically. But we'll call this x2 and y2. So now we can literally just plug in the formula. I strongly recommend anytime you need to use a formula, practice writing it, just so you don't forget it. But then you really have a strategy. You know how to categorize this problem and how to attack it. Again, make sure the y's are on top. So now we're just going to plug in y2, that's negative 9. I might even set myself up with the minus signs from the formula. Students tend to forget that. y2 is negative 9, y1 is 3. x2 is 2, x1 is negative 4. And this is going to happen so many times throughout this course. When you minus a negative, that becomes a positive. That happens a lot when you're calculating slope and some other things. So now you have negative 12. That's like if you owed me $9 for lunch and then $3 for a small sandwich, you owe me $12. And then 2 plus 4 makes 6. Our slope is negative 2. Let's just make sure we follow the directions, find the slope. We found the slope of that line. That means it's decreasing from left to right, it's going down. And it's something like that. You could think of it conceptually as down to right 1. And if I had a grid, you could kind of see this a little bit better. But just having that conceptual idea of how does positive slope look, how does negative slope look, and how does zero slope look, will really make things better. In this problem, they ask us to make a table of points. Now, I'm feeling kind of lazy. So, I strongly recommend you always find an x or a y-intercept, especially when you have a linear equation in this standard form, ax plus by equals c. It's really nice to get the x and y-intercepts, and here's why. Well, I'll get the y-intercept first, make x be 0. I'll get the x-intercept second. And then for fun, I'll plug in one other value just for fun, for x. Okay, so now I'm going to find the y-intercept. Again, that's making x be 0. Make x be 0. Okay, perfect. Now we want to figure out what y is. Well, let's just plug it in. That's what really you have to have the courage to do if you're working with a table. We'll make x be 0. And we'll figure out what y is. Now, some people call this the cover-up method because you're essentially just covering up x. It's just gone. Now, the inverse of multiplication by negative 3 is division by negative 3, and y is negative 2. That means our y-intercept is negative 2 when x is 0. Beautiful. Similarly, we can make y be 0. And so I'm essentially just covering up y, because negative 3 times 0 is just 0. And now I can solve for x, the x-intercept, when y is 0. And x is 3. And now, just for fun, just to show that you can plug in anything you so choose, let's make x be 6. 2 times 6 minus 3y equals 6. So you can really plug in whatever you want. You just might have some ugly fractional values, but that's okay. We know how to handle fractions. So now we just want to isolate y. We'll subtract 12 from both sides. We'll have negative 3y equals negative 6. We'll divide by negative 3, and y is 2. So now we know 3 points on our graph. Now that we have a nice table of values, we can graph this up. When x is 0, y is negative 2. Again, that's the y-intercept. And when x is 3, y is 0. That's the x-intercept. And what's nice, well, let's plot the next point first. We have 6, 2. What's nice is you can really tell that you're doing things correctly. So a picture, a graph is such a nice, helpful picture. You can tell we're going up 2 and right 1, 2, 3 to go from here to here. Similarly, we're going up 2 and right 1, 2, 3. So you can tell that we calculated things correctly. And the slope, just for fun, they didn't ask us this, but the slope is up 2, right 3. Now that slope is positive because from left to right we're going up. Similarly, you could say we're going down 2, left 1, 2, 3, down 2, left 3 for your slope. But a negative divided by a negative is a positive, so you'll still end up with a slope of 2/3. So we can make a graph, and you really only need 2 points. You could just find the y-intercept and the x-intercept, but I wanted to do one more for good measure. So here's an interesting situation. If you notice that in this case, the x values are the same, or if the y values were the same, the slope is going to be kind of weird or different or interesting. If you calculated this, if you did change in y over change in x, when you do the denominator, when you do x2 minus x1, you're going to have 0 in the denominator. When you divide by 0, we'll go over this later in the class, but in the course, but you essentially get either positive or negative infinity. That's undefined. We're not going to study infinity. We're going to study all real numbers, not including positive or negative infinity. So this is definitely weird right away. And let's say you did -5 minus -1. You had -4 here. This is not an acceptable answer for slope. You need to recognize, first off, that the x's were the same. Secondly, that we cannot divide by 0. So now you have either one of two options. Either the slope is 0 or the slope is undefined. And students tend to get confused by this and accidentally guess incorrectly. What I recommend you do is plot the points. Just make a quick little sketch. -4, -1. And -4, 1, 2, 3, 4, 5. Here's our 2 points. We have a line going through them. Okay, so this is a vertical line. Do you see how this is the x-axis and it's following that -4 hash mark? This is a vertical line. It's like a cliff. It's infinitely steep. So what is the slope of a cliff? How much does it, does it rise over how much does it run? Well, we say that this is undefined. If you think of slope, and so this is your final answer. If we think of slope as, then an undefined slope is a cliff. A slope of 0 is flat. So undefined slopes are a vertical line. And y is undefined. Well, we can't divide by 0. If you were to do this on a calculator, the calculator would freak out and say non-real answer. So vertical lines have an undefined slope. Alternatively, if the x's and y's were switched here, we could have a horizontal line. Let me just throw this on here. If we had a line like this when we graphed it, we would notice that the y values are the same. And that since the y values are the same, it's not changing. Since slope is a rate of change, since it's not changing, we would say that its slope is 0. Horizontal lines have a slope of 0. So be on the lookout. If the x's are the same, you're going to have an undefined slope. If you're finding the slope of a vertical line. And if the y's are the same, you'll have a horizontal line. And since the y values don't change, the slope is 0. Here, we notice the y values are the same. I'm going to graph this quickly. We have 3, 1, and we have negative 2, 1. Notice the y values are the same. So this function is not changing. It's flat. The slope is 0. It's not undefined. And if you were to calculate this, y2 minus y1, 1 minus 1 is 0, over negative 5. If I have $0 divided by negative 5 people, which is an awkward thing to think about, no matter what, each person is getting nothing. You each get $0 split evenly. You're welcome. So that's a slope of 0. It's flat. It doesn't rise, and it doesn't fall. It doesn't increase, and it doesn't decrease. It just always stays the same. It's always at 1.